Whoa, okay. Thanks for being patient, everybody. Let me turn off some of these overlays here. And we'll get started. So this is kind of an experiment. I just thought it might be kind of fun to do a live stream. This actually started out of the Facebook group for the Apple IIgs enthusiasts because I thought it might be an interesting way to collaborate. And yes, I do have a disco ball in here. This is my my secret laboratory full of Apple IIs and a lot of reference materials, and of course all of my turntables and vinyl as well. So for those of you that may have seen my presentation at Kansas Fest, this might be a little bit of a rehash, but if you read the description on the video, I'm really close to a full beta that I'd really like to put out, and I'd like to just kind of show some things. So let me kind of start with what I'm actually working on, which is an Apple IIgs emulator. Oops, I'm on the wrong screen. It's a fork of GSport, which is a pretty good emulator, and if you guys can't hear me or have any problems with the volume or anything like that, maybe let me know in the chat. I am looking at it. So I'm using GSport, and actually that is itself a fork of KEGS by Kent Dickies. And the whole reason I started this project was because, and this is actually kind of a funny story. About 2 years ago, I was getting married, and I thought it would be cute if I updated my profile picture. I had a screenshot of my Apple II, like the actual screen with Loadrunner from when Doug Smith had passed away, and I had that profile picture for a while. And I was about to get married, and I thought it would be cool if I put like a karateka screenshot of the end where, you know, the hero runs into the room and, well, then stops and meets up with the princess. And I thought that would be cool to put for my profile picture around the time I was getting married. And I tried to use GSport, and on the latest version of, I guess, Mac OS or OS X, whatever they call it, OS 10 these days, there was a problem with the pixel order. And so it was basically like a nibble order type of deal, and I just realized it was finally time for me to go ahead and dive into emulator development. So I did. I finally took the plunge, and I started on really trying to make a nice clean fork of, well, GSport and KEGS, but I really wanted it to be a lot more modern. So the first thing I did was I kind of revived an old fork of it that I had done, and so then after that, the first thing I did was rewrite the display driver, the keyboard input driver, the mouse driver, the joystick driver, and the audio driver, basically all the primary input and output devices. And I did this by targeting a library called SDL2, and previously it was using X Windows, Win32 APIs, things like that. And what's great about SDL is that it's available on a lot of platforms, Mac OS, Windows, Linux. You can get it on Raspberry Pi. I can use my Xbox controller on any of those platforms now, which is really nice. Basically any, you know, supported human interface device. And it makes it super easy to re-implement some features that were previously kind of broken, at least for me, especially under X Windows, like full screen support. So now we have full screen again. So enough of me talking about it. I will go ahead and just give you a quick look at it's basically kind of like I'll make this bigger actually. If you're familiar with launching KEGS or launching, actually let me make this a different color, it might be easier to see. That's not any good. If you're familiar with launching KEGS, you kind of have a config file. And it assigns whatever you have in your drives. And one of the things I also added is the ability to pass in, instead of just having a single config file, to be able to have multiple config files. So if I wanted to, for instance, let's say I have one, I think, for Zany Golf. Okay, so it's already got pre-configured for that. And I'll show you, it's just got a command line flag called config. And you pass in, I want to run the Zany Golf config. All right, that's pretty much it. This might not be the best background for this. Let me go ahead and change the display to a kind of a flat background. Sorry folks, this is what happens when you have amateurs like me. Okay, we'll just do this just for visibility. I think this might be a little cleaner. Alright, so as you can see, I've got you know, typical GS emulator. It's running Zany Golf. It has audio. It finally has full screen again. Right, so I hope that's not too loud. So tiny bit of stuttering there, but I'm also doing streaming and stuff. So normally it's runs at a pretty good clip. So I was very happy with that. This is actually all available right now. Let me. If you're sort of a developer type, it's available on GitHub as GSplus. That's the name of the emulator. Like I said, it has a couple of nice things like full screen and pretty good display and sound support. So I do not yet have packages, so you kind of do have to build it yourself, even though it does build for Linux, Windows, and OS X. I'm working on packages. I'm actually very close. Let's see. So just to prove that I am actually getting close, I finally did figure out how to, on OS X, make application bundles, because I do need to bundle in the SDL2 and FreeType framework. FreeType is used for printing. So anyway, that should be out really soon when I get all of this out, and that's part of the reason I wanted to show it off a little bit as I've gotten closer, because if anybody has any great ideas, I'm always open to suggestions. So yeah, you can go out to GitHub and build this version of GSport right now. It's you know, it's just a slightly modernized version of, sorry, GSplus. It's a slightly modernized version of GSport. Okay, so I got it to that point, which was a big goal of mine, and really the thing that kind of comes when you're a developer or anybody is what's next. You know, why did I really do that? Which is, I wanted to have a better functioning emulator, because I use it as my development platform. I do pretty much 95% of my development in emulators. I love working on the hardware, but that's kind of a luxury for a lot of the work. I'd rather have the fast iteration times that I can do with emulators. So I thought the real thing I need to build into this is a debugger. And I kind of have an issue with the way a lot of people do things like debuggers. You know, they plug it into their emulator. Let me see. So here's a really great emulator, right? I mean, Apple Win is awesome, and it's got a really good debugger, but I kind of can't stand this UI over here. It looks very amateurish. I don't like the way it's tacked on. The debugger looks cool, but I don't like the way it's plugged in. So I thought, how do I avoid this sort of problem? And here's another emulator. This is MAME, right? And it's got all these config options that pop up over the UI. Let me see. I think that OpenAppleQ, I've got a question on the chat from John Brooks about OpenAppleQ quitting out entirely from GSplus, and I can't remember actually. I believe it does. Yeah, so I'm not trapping it right now, which is fairly trivial to do, and that's one of the things where I feel like there needs to be somehow both. And an interesting option that I saw with Chrome recently is that they have an option that you can toggle where you hold down Open Apple Q to really quit. So maybe I could have Open Apple Q sent through to the emulator and hold it down to be a hard quit. And that's probably actually just a kind of a bug that I even have it set up that way right now, as I kind of just plugged in all of this SDL stuff as fast as I could. But that's a really good thing to bring up, because that's exactly the type of polish that I'm trying to get before I dump it on everyone else. So yeah, way to call me out there, John. Anyway, back to talking about debuggers and just sort of UIs in general. This is a UI for MAME where you do some of the machine config. And if you've used KEGS or GSport, I still support... Oh, did I lose my window? I still support the built-in configuration menu that was accessible via F4 in previous versions. So we do GSplus. I'll do that same config of, we'll run Zany Golf. Okay, and you hit basically F4, and it's got a configuration menu that looks a lot like the Apple IIgs, sorry, control panel. I accidentally killed my parent window there. Having some computer problems. I'm not used to trying to do it live. So, like I said, this is what you get with amateurs like me. All right. All right. Again, my point here is there is a built-in configuration menu. It works fine, right? You can see the same things that you saw in that text file. And of course, if you're like me and you use these programs, you're probably editing the text files, or I even have auto-generated ones for things where I'll hit build and it runs Merlin, and once Merlin makes something, it makes a disk image, and then once it makes a disk image, it moves it into the configuration, and then it boots, and that's all well and good. So I'm not trying to break any of that. We'll leave it there. But I am trying to do some things like add some extra command line functionality. So I started thinking, how do I abstract out a debugger if I don't want to put it in, some sort of overlay UI that I have to be the maintainer of that. And then if somebody else doesn't like the way my debugger looks, there's no real option for them. They can't make their own debugger and target it at my emulator. So I started thinking, I had this crazy kind of idea that for the debugger to act as a standalone control system, and it needs to be able to see inside the machine and be able to do things like start and stop the processor. And if you've used even software debuggers like GSbug or debugger cards, same sort of thing. You need to be able to interrupt the processor, you need to be able to inspect memory. And I thought, well, why don't I put a server inside my emulator and create an API that's kind of like a hypervisor API to the computer that is the emulator, right? Our emulator is a computer, really. And so I wrote a simple TCP/IP server inside of GSplus, and it's not like a web REST service. It's just straight sockets. You connect to a socket, you send a very simple command, and typically you'll get some sort of JSON response. So it's very easy to kind of write scripting language stuff against. And if you're not a programmer and this stuff doesn't really make exact sense, I'll try and show some of it in a little bit here. And you don't have to use it. You can still use GSplus the same way you've been using GSport, or the same way you've been using KEGS. But once you enable it from the command line, you have this incredible access inside the machine. So let me give you a quick example. We'll go back to, we'll just go back to running Zany Golf. And then this time, what we'll do, let me minimize this window and make the text a little bigger so you guys can see it better. Oops, sorry. I'm going to set a debug port. I'm just typically using 8000. Let me check the chat real fast. Funny, funny. Okay. So it's started GSbug, but it didn't actually do anything, right? Like, we don't see the Apple IIgs booting up yet. We just see that, oh, it says I've started and I've enabled the debug port. So we can actually telnet to that port. It's running locally, but I could have this running as a service and someone could telnet in remotely if I were really weird. Okay, so you can see that it is listening on the socket. It saw my connection, and so I issue a simple command, hello, which is actually in my thing, commands are basically terminated by new lines, so I just send a 1, that's the hello command, which actually, it basically initializes the emulator. And you can see it sent back this JSON, this big chunk of text right here. And if you're not really familiar with that, I'm going to go ahead and I'm going to send another command to the emulator, and D, which is actually to kill it. I'm telling it to die. Sorry, I'll try and embiggen the fonts a little bit more here. These are not the most readable displays. Alright. I hit D to kill it. But what I wanted to show you is what I got back. I just put it in a little web app that cleans up how it looks, and you can see when I told it hello, it sent back a bunch of information about the stack. It told me the stack location and what bytes were in the stack. It told me about all the CPU registers, and then it also showed me the current next approximately 10 instructions disassembled in case I wanted to have that in a debugger. So that's kind of the API response right there. So very simply, that's just a a little debugger interface, and it's only got about, I want to say, 12 commands, but you can do all these things with it just by coding against that interface. So I'll get into kind of some of those crazy possibilities with an engine like this later, but now I want to get back to the debugger. One of the big things I wanted to work on, because I don't want to be doing this. I want to be writing Apple II software. So I started to write a debugger kind of using this little telnet interface, and I wrote it in C++ using the Qt framework because it's a cross-platform GUI framework. So the idea is that I should be able to offer this in Windows, Linux, and OS X, whatever Mac calls themselves these days. So I'll go ahead and launch the main sort of programming tool I use for it. And I originally called it GSP launch because it was for initially just launching different versions of those little config files I was making. I'm calling it GSvision now. It's a separate deal from GSplus because you don't have to use it together. You can make your own launcher. You can make your own debugger and target this, but I'm making one so that you don't have to if you don't want to. So this is the big thing that I want to show off that I'm very excited to put out hopefully soon, because it adds a lot of functionality basically. And I've really been building it organically and just refactoring big chunks, so that's why it's not out yet. It's a little bit amateurish, and I've had to go back and rewrite parts as I've learned the Qt framework a little better and picked up more C++. So let's take a quick look. I won't show you the code here. I'm just going to go ahead and run it. And I'm going to get this guy out of the way in the background and hide some of these other windows that we're not using right now. Okay, so nothing, too incredibly sexy. You can see I just have a bunch of different menu items here that are different configs, and if I go into one of them, you can actually edit the config. You can see it's really mostly right now just setting up an emulator path to where GSplus is and then pointing to one of those config files, and then it passes that using that config switch. Excuse me one moment. A little parched. Okay. So you can set up a bunch of different configurations like this, and really all this is doing is calling it as a external process. It's saying, okay, launch this emulator with this config, but this is really nice because otherwise you have to go and edit that text file over and over and over, and you're kind of treating it like a single machine, whereas I can have these now pre-configured to, oh hey, I want to play Zany Golf, you know, play. Actually, let me redo that. I'm going to kill this debugger. I'm going to turn off the debugger for now. So yeah, I would just hit play, and you know, it's going to start Zany Golf. And if I wanted to play Silpede, you know, go ahead and play Silpede, and I'll start that one up. And you know, I could also start up Arkanoid. Actually, I think this is Arkanoid 2. Probably is. I probably just misnamed it. Yeah. Okay, and again, because of the rewrite to GSplus, and I mean, it was a fast emulator before, this stuff is all very trivial to run concurrently, you know. And sorry, you can enjoy the horrible amount of noise now. Okay, so you get the idea. I started with just a little launcher, and the reason I needed that was because I needed to also be able to pass in the debug options. So now I'll kind of bring back my development environment, because you'll see some debug output down here, which I might show off in a little bit, but this is the real app that I wrote right here, not the stuff behind it. This is just the development environment for Qt framework. So here's a little program that I use a lot of times just for testing, and it's you know, it's basically a little low res, draw some stuff on the screen. It's a ProDOS app. So it's just kind of what I'm going to use to show off some of the functionality here. So I'm going to relaunch it, but this time I'm going to enable the debugger. So you can see it popped up this big window that looks like what you would probably expect from a. Let me change the speed on this. Looks like what you would expect to see from debugging a 6502 CPU. So I'm going to hit refresh. What's in here right now is, remember when you send that hello command, it sends back sort of, here's my initial state before I've started. So this isn't really relevant, but you can refresh it. If I hit step, it'll stop on the next instruction, and it'll send me the disassembly, and I can start stepping through. So like I said, this is a ProDOS app. So you can see we're at the low 2000s here because it's a really small little program. And if I just step through it, you can see it's, what am I on? I am on some sort of delay loop, right? It's decrementing Y. So let me skip over this. I'm going to skip over this next one too. We're going to return, and you can see I've got color coding in here so you can see which instructions were skipped. I'm going to step to the next one and return back. And you can see the stack has updated because it just popped off. So how is this happening? What happens is if I hit something like step, all it's really doing is it's sending a message to the emulator over here. And it's saying, hey, you're at 2012. I know the next instruction is 2013. And sorry, I know that's probably not how you want people to say hexadecimal addresses, 2012. All right, and so basically it says update the program counter to 2013, you know, and that's it. You know, that's how, well, for step, it actually says run one instruction. For skip, it says just update the program counter. And of course, you can update the program counter yourself. You can see that as I'm editing the program counter, I'm going to skip over this little keyboard routine right here. And let me see. well, no, I'll just skip a couple opcodes up to 2018. Anyway, you can see that as I'm editing these, it realizes that there's changed data. So what you would do here is apply this data to set that to the CPU. And sure enough, it actually updated it, skipped from 2012 to 2018. Sorry, 200122 2018. Sorry, long day. Anyway, it's a debugger. You kind of get the point. And if I hit continue, assuming I haven't left the machine in a horrible state, which I have, it would just go back along its way. Let me just do that again real fast, just to prove that if I hadn't messed with whatever that one routine was. All right, so we step, continue, we're fine, right? You can set breakpoints. It's a bit buggy, but it's what you would expect, right? So I could set breakpoint at 2117. Okay. Now what you see here is basically the main bug I'm talking about right now is in the way that I'm catching the breakpoint actually happens to be after the opcode is or the instruction has happened. So not a big deal. I just didn't have time to fix it for this. What else would you expect from a debugger? Well, you see this window down here at the bottom. This is a it says RAM. You can see bank. So if I hit get, sure enough, it pulls back basically all of bank 0 because I have bank 0 in this little widget over here. We can go to the low res. You can see, yeah, that looks like low res data. Those are those pixels, you know, the 999999. Of course, you can edit it. This is not fully finished yet, and so one of the issues right now is that you can't type in ASCII over here on the right side, which you would expect to be able to do. But you can do that, and if I type set, it actually, you can see in the background, is building a list of all the memory positions that have changed. And if I type set, it only sends those memory locations as a sort of a long string of hex. So it's not a super high-tech API, but it typically works. And if I were to set a whole bunch of data, it'll actually break it up into multiple messages to send it in because there is a limit to how long the messages are. And let me see if I can bring up the window. And it might be, if it's too fast, you might not see it, but I'll hit continue and you'll probably see some of those memory locations. Oh no, I'm not sure what I did. Oh well. But you can actually, I'll kill this one. You can actually sort of edit the memory real time. You can actually edit the firmware banks. So if you want to start hacking on banks FF, FE, you know, or all 4 banks for a ROM 3, you can do that. Again, I'm working out some kinks on that, but it's kind of neat. So I won't get into sort of the version 2 yet, but I would like to eventually also include some sort of mini assembler along the lines of what you get in the monitor, because it's gotta happen, right? I can give you the ability to enter hex, but you've got to have the ability to also do a little bit of live coding on these machines for it to really reach maximum potential. Just another quick demo of not the debugger. This is a interesting program, a set of programs. It's a paint utility that Alex Lee of What is the Apple IIgs turned me on to. And I just wanted to show off a couple things here. So with the SDL support, one thing I'm really happy about, if you've ever used some of these emulators, look at how as I move my mouse, it captures right on the edge, right where it should. And as I move back out, it moves right back out into the OS host level, right where it should, right? So that's something that's sometimes been an issue if you've used some things like X Windows and it has this weird mouse stretching thing. And it works pretty well. And there's also some things, I don't know if this is with me, it seems to work pretty well in this mode, but sometimes it seems like it's a little off when you're using sort of the old school Apple IIe style mouse routines. But again, if you're using full screen, it's no problem. And the full screen is it uses a slight amount of aliasing, so I feel like it looks pretty good. It's not blurry per se. It's not one of the fancier sort of, I'm going to emulate NTSC artifacting. Eventually I would like to get there, and I do have some experimental code branches that have things like simulated scan lines. So that's another thing I would like to get in very shortly on the main GSplus branch, but I'd eventually like to get into trying to do some of those advanced display tricks to make it look like one of the old analog monitors. So let me see. And for those of you who've ever used GSbug, I'm a huge fan of GSbug. It works great. Where I started to find its failings is when I tried. Have you ever tried to debug interrupts with GSbug? You can't, because it's interrupt driven, right? So I tried to do the vertical blanking routine for an Apple IIc so I could get Flappy Bird on there, and it was really tough for me because it's and you have to use real hardware. So I'm hoping that you can do some things like that. And so let me look at my notes here, because I've probably covered most of the demo stuff, but yeah, I'd like to talk a little bit about some of the enhancements that I think I could do. So first would be the ability to actually edit your configuration more like you would a virtual machine right here. So if I were to edit module, right now what I've done is I've changed it to read only for this config file, because what the emulator does is what module tells it, eject the disk. So if you were to run this, it ejects the disk, and next time you run it, it says I can't find the disk. Because if you've ever seen that demo, sure enough, it has one of those cool fast loaders, and at the end it sends a smart port message to spit the disk out. So I'd like to be able to do things like enforce configuration, and also to be able to edit the configuration maybe on this launcher side. And right now it's just a very simple configuration thing, but I have this empty video tab. That could be other things. The memory footprint should be editable, things like that. And I do not yet have input rigged through the API, but I think that would be a lot of fun to be able to send in mouse, joystick, and keyboard commands specifically. You could do remote play. There'd be latency. But you could also do, I think, a lot more with orchestration. So if you're into the DevOps side of things, you could have, hey, run my GS app, do these weird things in the text editor, try all these different fonts, make sure it doesn't crash, right? Those are really useful things. So let me go back to the API a little bit and just show you a really sort of simple, fun demo. Oops. So again, there's maybe 12 commands for the API. It's things like get the CPU, set the CPU. And when I say set the CPU, you can set whatever you want. You can set the current stack register. You can set X, Y, and A. You can set all of the flags. There's get memory and set memory. There's step, skip. Actually, there is no skip. Skip is actually set CPU with just a different program counter position. There's continue, which tells it to stop stepping. So it's really simple, and you saw that I could type 1 to do just sort of a hello. So here's a neat little demo just to show you. This one's written in Python. I'll try and make it really big. I'm sorry, Joseph Carter, if you cannot see this. Hopefully the playback will be helpful. So you can see it has the same options, like connecting to localhost. I create a little telnet connection. I sleep like a fraction of a second. I don't even know if I need to. Then here's a little funny one. I put in those emulator speeds that KEGS has. I actually made it so now you don't just cycle through them. You can actually say go straight to speed 1, go straight to infinite speed. So right as soon as it boots, I say start the emulator, which is 1, send a carriage return. Then I say emulator special command speed 0. So in other words, I tell it as soon as you start, go to like hyperspeed, sleep just long enough to boot past GSOS, then because I boot GSOS to get GSbug, then switch back to regular speed so that my program starts running at the regular speed limit. So you can actually do this in your build scripts to shave time off of how long it takes to boot and see your program running, but still have it revert back to a speed that you want it to be. There's all these orchestration things you can get really crazy with if you want to. In this case, it's that little demo program, and it's going to sleep for 5 seconds so you can see the demo program drawing. And then what it's going to do is it's going to start randomly picking 2 spots on the screen every 0.0011 seconds and corrupting them. So I'll show you what this looks like. I need to go ahead and go back to, in this case I'm going to run my emulator separately here. GSplus. I'm using the default config that runs my little demo program, so I just need to tell it about the debug port of 8000. Okay, so it's listening, and now I run that tiny little Python demo, and it starts the GS. It sets it, well, it doesn't seem like it's at super fast speed, but I think part of the problem, yeah. So part of the problem there, let me redo that, because what's happening is since I put in such specific times, it's not going to be as fun right now. I'm just going to slow it down. Because I'm streaming, and I've got multiple cameras, it's eating up quite a bit of CPU, so we'll try this again. So you saw it skipped right past the boot basically into here. It's going to wait for about 5 seconds, and now you can see it's just writing into these memory locations as fast as possible. I don't know why you would want to do that, but you could. You can make it, you can very easily write a script that says save this chunk of memory out to the disk, and later on you could have it load back. You could have it start the emulator, and actually instead of using an operating system, you could have your own script place all these sort of binary objects wherever you want in memory and just start executing it, just to have that real full power of orchestration. So let me check through some of the comments here. Yeah, so I'm going to go start back with this one about it being sweet for teaching. One of the enhancements that I think I would really like to add to the debugger, if you saw the breakpoints, right? I set we'll start this, and we'll set a breakpoint at 002.117, kind of like I did before. So some of the enhancements I think that would really benefit from would be to have also breakpoints on tool calls and breakpoints on memory accesses. So it actually is on memory accesses right now. So it'll break on loads and stores to memory addresses, not just the PC register hitting that point. But I think it would be cool to have tool calls over here. And then right now what's happening is when it sends back the disassembly, and I don't know if you can see it, it sends back the opcodes. So down here it's got like 30, 0F, which disassembles as branch minus 2136. So I'm doing that disassembly in the emulator and sending it over, which is fine. I'm going to leave that in there so if it makes it easier to script against, but you don't really need that. I could build a much more powerful disassembler on this client side, and then what I'd like to do is be able to add templates. And what would the templates do? They would reveal tool calls, right? So in your disassembly you could see the tool calls coming up. They would reveal memory locations like cout or speaker, right? The ROM names if you want those, and maybe allow them to be toggleable. And then you could also send over debugger symbols, right? So you could have a template that has everything spit out of Merlin 32, and so you've got your debugger symbols inside of here. And so I'm not just looking at the branch minus, but I could actually have an extended view that has really what you would expect from a comprehensive, full modern debugger. Okay. Jeff Blakeney is asking about support for the cop instructions. I don't know much about it. I would like to I would like to basically learn more about sort of best practices around this, because there's nothing that says that I couldn't extend this API to real hardware, either via Ethernet or something like John Brooks actually was kind enough to remind me that, hey, serial ports are a thing. So you could do this and have a program running in memory, much like GSbug. Of course, you're still then limited by what you can do on real hardware regarding things like interrupts and how much you can abuse the system and still have your debugger run. But you could eventually possibly have this sort of thing orchestrating and debugging across multiple simulated machines, but then maybe even real machines, like a real ROM 1 and a real ROM 3, and then your future crazy ROM idea, whatever it is. So I don't know much about the cop instruction and how it works, and I never had one of the hardware debuggers back in the day. So if somebody wants to donate one of those Breakpoint cards or whatever, that'd be great. Sorry, I'm having a little problem scrolling. Oh, okay. Christopher Shepard was talking about writing web apps that pipe in and out code. I mean, you could kind of already do that. I guess I'm not exactly sure about where you want those connection points to be, but you could certainly make something like something that builds a customized game on a web app and runs it for that person, and just by sort of inserting it in the emulator. But you could also do that through your build pipeline if it was something like Merlin. So maybe I'm not getting the point there. So regarding those effects for Joseph, they essentially are OpenGL, if I'm not mistaken, the way that SDL is doing it. I mean, stuff like the scan lines right now, I'm just doing via transparent overlay, right, where every other line is some sort of darker line that's a bit of an alpha channel. You can adjust it, 25% darkness scan line, and it actually is adjustable in the code. I need to see what to do for the other stuff. I'm not a pixel shader guy or whatever, but when it gets to that point, which would probably be not even the next version, because I want to extend obviously the debugger stuff and make distribution packages is a big thing to kind of get off my list. So then I really can share it with everybody, even sort of the uninitiated. And I want to do some special things with that, like help people find the ROMs, so that if they drop this on their system, it kind of says, hey, you want to launch this, you need a GS ROM, maybe click here. Some things like that. And then once I kind of have that release, I'll hopefully solidify all the debugging and then get into actually extending GSplus, which isn't just the graphics, but I do want to kind of see where it is with the Apple Talk support and printer support. Those aren't huge for me, but I know I probably broke a few things in the GS port build, and if I can fix them, I'd rather do it earlier than wait 5 years and find out it's too hard. Well, I know COP is a software interrupt. I just have no idea how to use it. So one of you smart guys needs to teach me this stuff. Okay. Yeah, regarding a Python debug library, it could be anything. It could be your language of choice, which is, I initially actually wanted something a little bit closer to hardware instead of using TCP/IP sockets. like domain sockets. But ultimately, TCP/IP sockets are universal, right? And anybody can code against them, and you can do it in PHP, Ruby, Python, C#. And in my case, I'm using Qt, and I don't even know C++, and I was able to write this debugger. So, and the way a lot of this works in the UI is pretty interesting, because it's not like I click step and it does something to the emulator and it makes it give it a result. What happens is I hit step and it says go ahead and step to the next instruction, and as far as the UI knows, it's done. It's just listening, and when it gets a message back from the emulator's like, oh, by the way, I'm here, and then it updates this window with the next step. So it's very, very asynchronous, and you can ignore those responses if you want, if you're just doing the scripting like the Python scripting. For the debugger, I have to kind of have some sense of keeping aware of state, at least at certain points. So yeah, I mean, there's a lot of other fun stuff I could do. Like I said, the input would probably be useful, but I really want to get the debugger really solid, and I think that's pretty much it for the live stream. I don't need to keep talking just for the sake of talking. But I really appreciate everybody kind of joining in on this little experiment. Like I said, GSplus is already available at GitHub, and GSvision, gosh, I'm hoping I'm really down to the last 2 weeks or so, because I've gotten really all the features I've wanted. A couple other features I might want is GSbug allows you to kind of hit play, and it'll just it's kind of like hitting step as fast as you can until you stop it. Things like that really, each one of those probably would take me an hour, so I think I'm close. Feel free to comment on the video. Most of you guys, I think, know who I am and probably have another way to contact me, so if you want to try it out, and basically as soon as I have binaries available that are more distributable, feel free to hit me up, and I'll get you a copy. But eventually, when it is actually out, it should be really simple for everybody to install, and they can kind of do it piecemeal, one or both, but we'll see. I'm not really sure how to manage that. I'm not a product guy. I'm really obviously building this for myself and my own needs to kind of get enhanced debugging stuff. And I mean, I want to eventually go crazy and have it show the dock oscillators as waveforms and all that kind of stuff. So let's see. 2GS on Rails. Oh, you gross Rubyists. So, okay, back to the thing about the cop instruction. It does that right now, actually. If it hits a break, and actually if it hits a cop, I guess I have seen that, the coprocessor, I don't know how you pronounce it, because that causes an interrupt that halts execution, my emulator picks it up and sends it back, and it basically drops you into step mode. So that actually is the case right now. If you build some code and you put a break in there, it'll actually kind of jump back out to here, which is, I think, good. If you don't want that, you just don't enable the debugger, and then it goes to the monitor or whatever your built-in debugger. I will check out the starter kit that you guys have for downloading the ROMs and things, because again, I would like to solve that nut. We get a lot of those posts on the groups. Well, maybe not all the time, but people kind of just they download an emulator, and I feel like it's harder than it should be. Part of that is because we have the fear of distributing certain things, and that's somewhat legit, but I'd like to figure out a way to just point them at some sort of torrent or something and be like, well, I don't know, it's out there, go get it. And so that they can kind of have at least a wizard that gets them through to where they get to this point, because this point is cool when you can just go ahead and say, oh cool, now I got this thing, and hey, somebody's put out Alien Mind, and I can play it. Oops, and I broke that one. Haha. Never mind. Ignore the man behind the curtain. I break a lot. All right. It's late again. I'm sorry for the Europeans that I timed this horribly for, but thanks you guys for watching. Just hit me up online. We'll do this again. Thanks for nerding out on a Friday night. That's all I got. Peace.